Hello everyone, I'm Swapna. I'm here to discuss how AutoML is transforming enterprise site reliability engineering practices. So, we will discuss in detail how the organizations are getting leverage with this process. So, when it comes to the site reliability engineering, it's a fundamental transformation through AutoML. The revolutionary approach is redefining how organizations monitor and predict and respond these reliability challenges. It is applicable for across industries. We will explore how AutoML is democratizing AI powered reliable analysis and predictions, all the maximum re- services which we can integrate with this AutoML. So, earlier in the traditional operations, the manual monitoring was quite challenging and it was time taking process and it was giving lot of errors also, and sometimes the results will go in different directions. So if it is the LRSRE adoptions, the software engineering principles with the basic automations or log monitoring or anomalies, these kind of protocols is integrated in LRE adoptions. But coming to the modern SREs, it is emphasizing on service level objectives, how the instance management work and how it can be leveraged with this process. We can go for the modern SRE. But nowadays, with this cloud, we have a AutoML enhanced SREs. So with this integrated AutoML, we have all the predictive analytics and alerting mechanism and how the remediation of this uh, alerts, anomalies, or errors, all this we can predict in advance so that we can get benefit out of this and the projects also will run successfully. So this journey is from traditional operations to SRE, how this continuous process and it's a proactive process. So we need to check back and forth and the system complexities and we can incorporate this process. So when it comes to the why actually enterprises needed this site reliability engineering, because nowadays the scalability is high, this applications are the traffics of applications are high, and the capabilities of this infrastructure rules has become high, and even the architecture's complexities has been increased. And when it comes to the development, it's a continuous processes evaluating and cycles, release cycles, SDLC process, all are been increased rapidly, and user expectations also. They don't want to tolerate even the fraction of seconds downtime, and even the standards. They believe that the revenue loss they cannot afford it, and financial impact. Eventually, these outages can impact the financial processes, and engineering efforts also will be more. So this brand damage also will occur with this if we do not identify the process in elder stage and if we don't address it. So here, how AutoML is transforming this SREs. Some use cases is kind of instant predictions or preventions. If you can predict any of the server failures in advance or any traffic or error spikes, that is, we can mitigate in advance by predicting this one. So that we can prevent it. And sometimes we can go for the root cause analysis. Most of the time it is uses because it's correlate matrix and it identifies the pattern, how the logs has been identifying, how the events are continuously occurring. These we can most likely we can go for the root causes. And it reduces the downtime for helping SREs to fix the things, because if we know the problem, then we can identify the fix immediately and we will be very preventive. We fix all these issues. So that's the reason root cause analysis will be easy and helpful to fix faster way. And when it comes to the capacity planning, so when automated ML is forecast system outages, so you can mention that how this traffic surges and what type of overloads can occur, and if we prevent it, and or else if we predict it, we can increase the size and infrastructure allocations, all this bandwidth, so that we can save the money in the cloud services. It is auto scaling, so whenever the services are increasing, so it will be the cost will be high. If we don't have a services much, I mean, if we are not leveraging most of the time, so then we can reduce the compute so that we can save the time. Then other one is automated alert tuning. If too many alerts are coming, and the automatic ML will identify whether these are true or false. If it is false, then it will ignore, because sometimes we don't even know that the spam kind of mails, like the alerts also not accurate, and we may tend to that to be considered, and towards we end up the time to fix those things, which is not even uh, impact of any of the process. Then that kind of will be analyzed in the automated alert tuning. So then only we will have a meaningful alerts sent to the engineers, so that they can only concentrate on which are really useful. And self-healing systems, we can define some of the process. If, for example, the downtime is high in during particular time, and only the restart is required, that we can tune it if it is reaching this threshold value, and then we can mention that the rules which are we can define easily, and automatically it restarts. So that attention we need not to give. So it will automatically fix, and eventually all these things we can get implemented. How earlier the traditional MLs was going, so it was a massive process where time taking and the efforts also more. So when it comes to the data acquisition, so all the cases that predefined data will acquire it, even the traditional and automated. But after this, when it comes to the data exploration too, data preparation and feature engineering, then model selection, model training, and the parameters for performance tuning and model evaluations. These all process will in the existing in the traditional ML, but whereas in the automated ML, so all these will come up with the machine learn automated system, where we can only insert the data, and we can give some metrics, and sometimes we can, if we are really budget friendly, we can give the time and cost, so that it will consider all these parameters which we have given. And this is the black box, and where you can also mention, if you are really sure about the process, then you can mention. If you are not, then you can take the approaches from this automated ML, that features, algorithms, all these parameters, we can mention it. And then after this, it will consider various train and test data, and it will give the results, and that will give a rank and accuracy for us. So out of this, it's your choice to discuss and decide among of this, and you can get benefit out of this. So this is how that auto ML process is very easy, and without having much knowledge in the data science also, we can go for it. So, and coming to the auto ML transforms, SRE workflows, we can do this in the better way. As first, we can go for the data collections, and the future engineering and monitoring resources can derive from there. And the model selections and training, this algorithms is models, this only the reliability scenarios, whether it is a prediction, or then it will choose the prediction models. And anomaly detections, if it is continuous monitoring and recognition behaviors that exist, so it will identify those, and it will monitor for it. And predictive responses also automated the tool actions, this adjustments, whatever the predict insights it gives, if you can mention in that parameter, so that it will automatically consider it. So this streamlined analytic workflow, it's eliminate all the manual efforts, and model tuning also, improving this accuracy. Coming to the practical implementation framework. So whenever you wanted to implement in your organizations, So then you can go for the assessments and planning. Then evaluate the current SRE maturity, whether it is working fine or you wanted to go for the automation. If it is a maturity of your manual process, then it is fine. But most of the cases, manual intervention is more. That so then identify this high value use cases and what is the success metrics. Then whatever the existing process, you can document it and you can see the automation. Then you can see the differences. If it is come to the data preparation, that whatever the data monitoring data is available, and you can establish the quality baselines and some labels you can create it, and even that it is used for supervised learning. Platform selection. There are three platforms, if you can assume it's the most predominantly using by organizations is Azure AutoML, and Google also is having this feature, and AWS also. It's up to the organizations what services they can use it, what cloud they can go for it, they can select it, and most of the cases, every platform is working in the similar approach. So then that specific use cases we can consider cloud native and vendor neutral options. Then pilot implementations, you can please start with the well-defined pilot projects and assess it, and how the transition is automated process, you can go for the implementation. Then scale and optimize, expand this additional use cases if you're comfortable with the model performance, and you can go for the large group of things and you can go for the continuous improvement. So that's how the project will go live, and you can compare the results and you will be good than the manual results versus automated results. And when it comes to the key operational metrics improvement, now, it has been around, as per the statistics, it has been 68% time to deductions decreased this process, and faster 42%. Mean time resolution is improved across with 48 percentage, and alert accuracies are very high. This is around 91% as per the statisticians, and the coverage expansion is tripled, and these all key metrics which organization consider into it. And if next steps, if you wanted to go for it, then the conduct some audit cases and some take of the 2 to 3 high level use cases and discuss with the cross functional teams, because all stakeholders, engineers and data scientists, all if they involve, so we will have a good understanding what are the major problems and how we can address those issues and how we can come out of the situation by reducing the downtime or anomalies, error prone. And this, you can launch the pilot project in the AutoML later, once you are comparing with the manual results versus AutoML results. Yes, there are some implementation challenges here too. For example, if you go for the data quality issues, there is an inconsistency and incomplete in the monitoring data. That time, what we can suggest in this solution, the data validations pipelines is inputs and all, this should meet the standard process, because if the data is accurate and if in correct data and if there is relation between the data, so then you will have a correct output. So you can check when you are passing this data to the model, then automatically the quality issues will be resolved, and the scoring also will impact if you do not pass the data properly. And organization resistance. Yes, SRE teams is trusting automated process is difficult, because there are some critical decisions also be taken, of course. But what I suggest, you can go for the non-critical systems, and if you have a confidence and go for the side-by-side comparison, how the manual results and how the automated decisions. So eventually, If you see it, so you can go for these approaches. Integration complexity. Yes, connecting AutoML outputs to existing this monitoring tools. For example, if you have a platform specific tools and it is hard to integrate at one stretch with the AutoML process. So for that, we can leverage standard APIs and some architectures to create some loosely coupled integration points. But now with the cloud, AutoMLs are providing lot of features. We can get leverage with those and we can go for it. So the successful implementations, all the way it is required thoughtful discussions and the technical and organization challenges. Some domains, most of the domains are using this one, but how much the domains are getting leveraged. So I just wanted to point out some of the areas. For example, if you take the financial services, this automatically predicts the how much load during the market hours or stock exchange timings. If it predicts it, and then during that, we can make a decision during these peak hours whether we can scale out and increase the resources. We can decide in pre- preventive measures also, we can take it. And it can detect anomalies in the transactions or server level logs. If any fraud or system failures, that also we can detect it. So hence we can take a good action on it. And if you go for the e-commerce, if it is, we predict the traffic spikes, how the sales time be Black Friday or New Year time or any of the during holidays. That time that sales services is high and we can expect the peak hours during that. So it automatically predicts and we can it pop up to us in advance so that we can take a decisions to how to improve the compute engines. Or this is also detect the anomalies and if any revenue loss from the failed payments and all, so that we can take care. For example, if the one payment process is not going through well all the time, so that we can have a preventive measures to opt it. Then other healthcare. This healthcare monitors IoT devices and patients' data systems. This EMR medical reports also is the predictive maintenance can be happen. And the same way, telecom industries also, we can detect outages in the real time and the failover routes also we can identify it. We can forecast usage patterns, how the bandwidth allocations in the infrastructure deployment. Yeah, here I would like to conclude saying AutoML is not a replace of SREs. It only enhances. The tool is getting used, the capabilities of SRE practices, how we can automatic routine analysis, our decision makings, our anomalies, our fraud detections. These kind of scenarios are peak hours. These SRE practices, whatever we are doing in normal basis, manual basis. So we can go for this approach and we can think in the strategical way and then we can have a decisions out of this. This allows SRE to focus on only strategic tasks. But when this heavy load is there, then that time it is hard to take a decisions with the specific tools and the tool compatibilities and all. But whereas if it is AutoML, it handles very well. So this is what I wanted to conclude here. So thank you so much for this giving this opportunity.